Thank you. Thanks very much. Okay, I'll start sharing my slides.
Yep,
just let me know. Okay.
Yep, can see.
Good. Thanks. I'll just put it on presentation mode.
Yep, perfect.
Great. Okay. Thanks. Well, thanks very much. So yeah, I'm going to be talking about a method which is known by various terms, but for the purposes of this presentation, I'll stick to the term mitigation outcome assessment. So this is a little bit of a well, it is a departure from LCA, but I will talk about how it compares and relates to LCA during the talk. So just to give a kind of overview or an agenda for what I'll cover, I'll start off by giving a brief overview of this mitigation outcome assessment method. I'll then talk about some of the standards that exist related to this method. I'll then talk about some of the differences between consequential life cycle assessment and an MOA. And then I wanted to talk a little bit about the way in which there are some instances where attributional LCA is being used, arguably in some contexts where MOA would normally be expected to be used. And then I was going to sort of pose this question: why is an MOA more widely recognized and used? And then finish off with some thoughts on future development. So to start off with, just to give a sort of a first sort of introduction overview of what this method is about. So this sort of illustrative figure gives a sort of simple presentation, perhaps overly simplistic presentation of the structure of the method. And essentially what the method is doing is identifying a baseline scenario, and this is defined as the scenario that would exist in the absence of the intervention that is being assessed. Then the method, well, for that baseline scenario, you would quantify emissions and removals occurring in that scenario. You'll then do the same for the intervention scenario. You'll look at all of the emissions and removals occurring in the intervention scenario. And then the difference, the difference between those two scenarios is the change caused by the intervention that's being assessed. So very much the purpose of this method is quantifying total system-wide change caused by an intervention. And one thing to note is that the structure of the method is flexible. In this particular illustration, I have an intervention which is lowering emissions relative to the baseline, but you could just as easily have an intervention which increases emissions relative to the baseline, and your intervention scenario would just be above the baseline. And the simple calculation to calculate the change caused is just the intervention scenario emissions minus the baseline scenario emissions. That gives you the change caused. And just to touch on it now, the other thing to note is that this method is very much giving temporal information on when emissions and removals occur. So it's structured as a time series, and I'll talk a bit more about that just a little bit later on. So some other things to note by way of sort of background. This method in principle is very, very generic, so it can be applied to any scale of intervention. So it can be applied at kind of macro scale interventions, so things like government policies, taxes, subsidies, mandates, and so on. It is quite often, or the majority of applications is for the quantification of change by projects. So things like building a wind farm, tree planting, something like building a data center, you could apply this method to calculate the total change caused by change in emissions caused by building a data center. but it can also be applied to micro level interventions, so individual choices and decisions. So a decision to cycle to work, or the decision to buy a product like an electric vehicle. And something else to note, and yeah, I should flag this. I'm very much going to be talking about it in terms of the quantification of greenhouse gas emissions and greenhouse gas removals, partly because that is generally the way in which the impact category to which this method has been applied. And it's also happens to be the focus of my own research. So I tend to think in terms of carbon accounting and greenhouse gases. But that's not to say that you couldn't apply the structure of this method to any impact category. I'm just going to be kind of inevitably talking about mostly greenhouse gases. And then something else just to mention by way of sort of background is that there isn't really a sort of well-established universal name for this method. So I'm calling it Mitigation Outcome Assessment, or MOA for short. And I've largely taken that term from the Paris Climate Agreement, which talks about mitigation outcomes, and this type of method is used for market-based accounting under Article 6 of the Paris Agreement. So that's where the label, the term mitigation outcome assessment comes from. But it's also known by a number of other terms. So occasionally you see it referred to as consequential time series accounting or method. Sometimes it's been referred to as a baseline and credit quantification method. And more commonly, it is referred to by the type of intervention that is being assessed, rather than having a generic term for the method. So quite often it's referred to as project level carbon or greenhouse gas accounting, or policy level carbon accounting, although the structure of the method is identical across those two applications. It's just the same method applied to a different scale of intervention. So anyway, there isn't really a single established name for this method. So yeah, the next thing that I wanted to sort of touch on and talk about are the existing standards that are out there. So although this method, arguably in some ways, it's not as widely recognized and used as it could be, nevertheless, it has quite a long history of standardization. So we have things like the Greenhouse Gas Protocol for Project Accounting, which was published all the way back 20 years ago in 2005. We also have the ISO standard 14064 Part 2, which talks about project level quantification. And so that standard was last updated in 2019. It is actually now open for revision at the moment. So ISO is currently working on a revision. And just by way of a kind of digression, the GHG protocol and ISO have now agreed to team up on their suite of greenhouse gas accounting standards. So the GHG protocol will also be involved now in the revision of 64 Part 2. So those standards that I mentioned on the previous slide, they are generic standardized methodologies for quantification at the project level. There are also quite a large number of project type specific methodologies, and this is particularly within the field of carbon offset quantification. So we're just seeing the start of the publication or the development of individual specific project type methodologies under the Paris Agreement crediting mechanism. And that follows on very much from the clean development mechanism. So there's a huge library of specific project type methodologies. So there will be a specific methodology for renewable energy projects, or clean cook stove projects, or tree planting projects, and so on. So as well as these generic ISO and GHG protocol standards, there are project type specific standard methodologies out there too. And yeah, so things like the Paris Agreement and the Clean Development Mechanism is very much under the compliance offset market. There's also a large number of standardized methodologies for the voluntary carbon market as well. So that's largely on the project application of this mitigation outcome assessment type method. The GHG protocol also has its policy and action standard from 2014. So this really is very much the same structure of method, but just intended for application to policy level interventions. And yeah, so larger scale interventions than at the project level. And I think a final thing I wanted to mention on standardization is there is a grouping of international development banks and other international financial institutions who have published quite a large amount of guidance on how to implement this type of method as well. And it goes under the title of Harmonized Standards for GHG Accounting. So not a very specific descriptive term in terms of the type of method that they are intending, but that what is published by this grouping is a form of mitigation outcome assessment. Yeah, and their guidance goes back to 2015. So again, quite a long, reasonably long time frame for standardization. So the next thing I wanted to talk about is some of the key differences between consequential life cycle assessment and mitigation outcome assessment, because they are largely doing the same thing. They're both aiming to quantify the change in emissions caused by a decision or intervention. And one of the first differences, or the first difference that I'll talk about, is the way in which mitigation outcome assessment has a very clear and transparent and separate baseline and intervention scenario structure. So as I mentioned, the baseline is the scenario that would have existed in the absence of the intervention or decision that is being assessed. And consequential LCA does also effectively have a baseline, but it's rather more implicit and often isn't explicitly modeled. So for consequential LCA, often the framing is for a decision to produce or consume or demand X number more units of product or function. And very often the baseline is implicitly the situation in which that decision does not take place, and the baseline is no extra units of function are produced. But you could, with a consequential LCA, also have other forms of baseline, like an alternative product that is supplying the same extra units of function. But where I guess the difference is more significant is the way in which consequential LCA will tend to give a mixture of impacts or emissions that are occurring in the intervention scenario together with avoided emissions that would have occurred in the baseline. And you see this in particular with the way in which consequential LCA will model and deal with cases of multifunctionality like co-products. And CLCA will typically use substitution method to do that. So this is the method where you identify the products that are displaced by the supply of co-products that are caused by the decision to produce or demand extra units of the main product which is assessed, and then crediting the avoidance of impacts or emissions or burdens associated with those products which are displaced or avoided. And to give a simple example of that, if you're looking at to consume more beef then that decision will cause an increase in the supply of co-products like low-grade offcuts or offal. And those co-products can be used for a number of things, but one of the things they can substitute for is primary production of other inputs for pet food. And under the substitution method, you would identify what the emissions are from that primary production, and you would credit the displacement or the avoidance of that primary production to the decision to consume more beef. But the key point here is that the emissions that are avoided, they are emissions that would have occurred in the baseline, but they don't in the intervention scenario. For MOA, that would be modelled very transparently as emissions occurring in the baseline, which don't occur in the intervention scenario. But presentationally, CLCA in the final number that you get just shows you the total change and lumps together the emissions caused by the decision as well as the avoided emissions as well. So you don't have that very transparent separate modelling of a baseline scenario emissions and intervention scenario emissions. I mean, this is largely presentational. The end result number in terms of the change in emissions isn't different. It's just the presentation that is different. But something that is probably more significant as a difference between MOA and consequential LCA is the way in which MOA will plot when emissions and removals occur as a time series. So you have information, temporal information on when emissions and removals occur. Whereas CLCA or LCA generally just is not good at modelling when things actually occur, whereas MOA is explicitly modelled as a time series. So this is just to sort of illustrate what the output from an MOA looks like. This is from a study that I published, I think in 2015, possibly. And it was looking at the total change in emissions caused by the decision to build a bioheat plant, actually for St Andrews University. And what we have here are these two. I'm just going to see if I can get my pointer to come on. No, I'm not sure.
Matthew, you've muted yourself.
So sorry about that. Am I back? Hello?
Hello? Yep.
Hi, Justin. Sorry about that. I was trying to get the pointer to work, and I somehow managed to mute myself instead.
It's okay.
Yeah, thanks for letting me know.
Yep, no worries.
Good. Okay, so I'm going to talk through this slide. So yeah, what we have is the output from a MOA for a bioheat plant. And we've got the two scenarios. The dark line here is the decision or intervention scenario. The dashed grey line is the baseline. And what we have for the first 25 years, that's the lifetime of the bioheat plant while it's operational. And the decision scenario emissions are higher than in the baseline because we're burning woody biomass. And woody biomass has higher emissions when you burn it. More CO2 is released when you burn it per unit of energy compared to natural gas. So we have a period of time while the bioheat plant is operational where we're increasing emissions to the atmosphere relative to the baseline. And then what you see once the bioheat plant reaches the end of its operational life, then you can see from the lines this underlying effect that was occurring where through replanting the forest that has been harvested to combust in the bioheat plant, we have removals of CO2 from the atmosphere as the trees regrow. And so this decision scenario curve is just showing the growth curve for the trees as they're planted and regrow. So we have a period of carbon debt during 25 years that the by-heat plant is operational, and then we have a carbon payback period. And you can't read it immediately off the graph, but you can calculate that the carbon payback period is 75 years. So it's only after 75 years that the by-heat plant reaches the point where it's going net negative. It's reducing emissions compared to the baseline. And so that's very useful information. It's useful to know when emissions and removals are occurring so you can quantify carbon payback periods. It's also useful to have this kind of temporal distribution so you can apply things like time-specific emissions factors. So if you have something like a decarbonizing grid and you're looking at the use phase of a long-lived product like an EV, if you have this structure, then you can apply time-specific, year-specific marginal emissions factors over the lifetime of the product. So that's a second key difference between MOA and consequential LCA. Now I wanted to just now quickly talk about attributional life cycle assessment and removals, because this is a sort of slightly strange, possibly worrying, I think probably worrying trend that we're seeing. This is within the carbon offset removal space, where a number of certification standards are starting to use attributional LCA to quantify the net change in emissions and removals caused by removal type projects. And that's problematic because attributional LCA doesn't show, and nor is it really intended to show, the total change in emissions caused by an intervention. So it's just fundamentally not the right message, not the right method to use for carbon offset quantification, where the purpose is to quantify total change. And just to give a kind of brief example of that, yeah, ALCA uses direct or average data rather than marginal data. And so if you have something like electricity consumption as part of a project like direct air capture with carbon storage, which uses a lot of electricity to capture and compress CO2, using average data can massively underestimate emissions. So in this example, the grid average factor for Brazil is around 133 grams per kilowatt hour, whereas the grid margin is around 201 grams of CO2 per kilowatt hour. So you can end up with quite a high over issuance of carbon offset credits if you use attributional LCA. And what's slightly strange in this situation is that MOA, or some form of MOA, has been in use for quite a long time, 20, 25 years within the carbon offset space. So it's a very strange occurrence now, and it's particularly within the field of removal offset crediting. For some reason, standard setters have been using attributional LCA, and I flag it as a sort of an issue that's occurring. And that sort of also leads me on to the second to last thing that I wanted to talk about, which is this question of, well, why isn't MOA more widely recognized and used? I've sort of suggested that it has some advantages in terms of transparent baseline and intervention scenario and this very clear temporal information. So it's it's an interesting, important question to ask. Well, why isn't this method more widely used? And a first thought on that is to look at what's been happening in the carbon offset markets, and this is really sort of conjecture for what's been happening in that space and how that impacts on the use of different methods. And what this chart on the left shows is the price for certified emission reduction credits. So these are credits from the Clean Development Mechanism, which was the compliance carbon offset market under the Kyoto Protocol. And what you can see is this sharp decline in the price of certificates in 2012. And as a result of that, lots of people, lots of practitioners and expertise left the compliance offset market. And the chart on the right is for the voluntary carbon market, which has typically always been a much smaller market. But you see a similar sort of trend, particularly down to 2017, where that voluntary carbon market shrank enormously. And again, lots of practitioners and experts within that field left the voluntary carbon market. And what we've seen is a continuing strange trend where the market suddenly increased and grew very, very rapidly in 2021 and 22 and has come down again. But possibly what we've seen is an influx of new practitioners into that market who don't necessarily have the institutional legacy knowledge on methods that were previously in existence. And this is particularly the case for novel removal technologies, which didn't exist in earlier years of the compliance or voluntary offset markets. So new companies, new certification schemes are being established, they're employing new people, and they're saying, how do we quantify the change in emissions caused by direct air capture? And people are just reaching for the methods that they're aware of, which aren't necessarily MOA. They might be things like LCA, attributional LCA. So this might be part of an explanation for what we're seeing in the offset market. And then, yeah, just a few other thoughts on factors that might be holding back this method. One is the thing that I mentioned at the beginning, that there's no single recognized name for the method. And names are important. I think if you have a clear recognized name that is largely descriptive of the method, that can be very impactful in terms of dissemination and increasing understanding. So that's one potential issue. Another one is the lack of a generic standard that articulates the method in a scientific way. We have lots of standardization for specific contexts like project level accounting or policy level accounting, and for specific carbon offset project types, but we don't have this sort of generic scientific articulation of the method, and that could be a barrier. There's also the perceived complexity of the method. Identifying marginal systems is often perceived to be difficult, and I think this probably applies to consequential LCA as well, as one of the factors that's held back the wider adoption of consequential LCA as well. Certainly in the case of MOA, there are relatively few academic studies that exemplify how to use this method, and I think this is something that's very very good within the LCA community. There is a lot of publication of studies, both by academics and by practitioners, publishing in academic journals, and that helps to disseminate the nature of LCA. And relatedly, you see very few PhD students who are trained in the use of MOA. And again, this has this sort of knock-on effect. When PhD students graduate, they go and work in industry and in places like the removals offset market, and they take with them the methods that they've been trained in. And so if students are often being trained in attributional LCA and not MOA, that's the method that they're familiar with and the one that they will pick up first. And then institutionally, this is again something that I think the LCA community does very, very well. It has dedicated journals, it's got dedicated conferences, which creates this sense of community of practice. And this seminar series, if you like, is a good example of that. It brings people together to share methods and studies and so on. So the final thing that I wanted to just touch on is just a few thoughts about future development. And one is on the possibility of developing a generic method or standard for MOA that arguably could be helpful just in terms of, providing a resource that anyone can go to, whatever the scale of intervention is, whether it's a scientific study, whether it's for a very practice-focused application. The development of a generic standard could be useful. Something else that I think would be very useful is to develop something like a conference to share knowledge across different areas of practice. And I think what you see with MOA are some fairly well-developed areas of practice. So things like the multilateral development banks, the carbon offset community. There's also quite a lot happening in terms of corporate level reporting on avoided emissions. But those different communities of practice tend not to speak to each other. They're quite siloed, and having a process like a conference could help to shape this idea of a broader community of practice. And then the other thing that I mentioned before is the lack of a good name that sort of adequately captures or describes what the method is doing. And something, names do matter, and they can be very, very impactful in terms of dissemination. So obviously for this presentation, I've been calling it mitigation outcome assessment. But it's a kind of open question about whether that name works or whether something else would work better. But yeah, so thank you very much. That was everything I was going to present. And then I'm really happy to sort of take any sort of questions or comments that anyone has.
Great, thanks, Matthew. We've got a few questions in the chat, but if anyone would like to address Matthew directly, you can raise your hand and unmute yourself. So no one's raised a hand yet, so we'll go through what's in the chat. So the first question is just a clarification on the use of attribution on LCA. So just the clarification is basically, is the methodology by Puro Earth and isometric is flawed? Just to clarify, that is what you're saying.
In a nutshell, absolutely. I mean, I think things like the the electricity example, and this is something that has there's been awareness of this as a methodological point for a long time, that if you want to understand the change caused by an intervention that increases demand for power, the change is the marginal generation system that dispatches or is built in order to meet that demand. It isn't that the grid average does not represent the change caused by an increase in demand. So you need marginal factors or marginal data in order to quantify that. So it does seem like a very retrograde step. And particularly within the offset community, that common practice has been to calculate marginal emissions factors for the last 20 plus years. So it's a kind of strange backward step. I think you could imagine someone making the case, well, there's high uncertainty about how to calculate marginal emissions factors, but then I think you'd have to make the argument that in some way the grid average is representative of the margin, or is likely to be a reasonable proxy for the margin. I don't think anyone's arguing that it isn't the margin that you want to know.
Yeah. And just a follow-up to that, so another question, just asking on your thoughts on how to fight against the improper use of attribution at LCA in the offsetting and potentially the insetting market as well.
Gosh, what's the question? How to fight against it?
Yeah, so I'll just read out the full question. So any thoughts on how to fight against the competence greenwashing in carbon offsetting certification sector? For example, wrong people in inadequate technical background expertise, put in wrong positions. Um,
Yeah,
yeah.
gosh, I mean that's a that's a it's a good question. I mean these standard setters have consultations
Hmm.
periodically on their standards, and so there's opportunities to feedback and for practitioners to feed in, for academics to feed in, and make the point that there is a long history of standardization in this area, and that
Yeah.
these new emerging certification standards should really look to that as best practice.
Yeah.
Um, yeah, and yeah, so I think I think
Yeah.
for individuals that's one route.
Hmm.
Um, but yeah, it is a strange problem. I mean, it's very strange. I don't know. Maybe strange is the wrong word. It's not good when you see methodological development improving over time and then it taking a backward step. It's never nice
Yeah.
seeing method development going backwards.
Yeah.
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 Um,
Yeah. 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 Absolutely. Bo, you've raised your hand. You should be able to unmute
I
yourself.
unmute
Okay,
myself,
there you
yes.
go. There you go. Great.
Hello, Matthew. It's good to see you.
Good to see you.
Um, I was wondering why you now invent a new word, MOA, which is really the name for an extinct flightless bird, rather than just using the term CLCA or consequential LCA with a time explicit modeling, because we are, of course, in the LCA field, blatantly aware that we have not been very good at modeling our outputs time dependent. We do so with our forestry models, with indirect land use change, with the building LCAs, which obviously have a long time horizon. But I think it could be done generally, and I mean, I would point to the work by Romain, what's his name? Romain Sacchi, yes, who just published an extension to the Brightway LCA software called Edges, which helps people do this in practice. And I think this will become within the next few years the standard way of doing consequential LCA. So by inventing a new word for the same thing, you're just shooting yourself in the foot, I think.
Yeah, I mean, I think, I'm not wedded to any particular name, to be honest. I mean, I think, so it's possible to say consequential LCA with time series. I mean, some of the reasons why that, well, it could work. Some of the reasons why it might not be so great is that things like project level offset accounting developed, as far as I can see, very independently from consequential LCA. I mean, they're two methods broadly doing the same thing, have the same objective, but those communities were largely separate, and so the project level offset accounting community probably wouldn't recognize LCA. They would say, well, that's kind of project, that's product level stuff. That's not what we're doing. We're doing project level work. So you need something that's kind of um, level agnostic, suitably generic, that is descriptive. And the term LCA actually works really quite well for LCA. It is life cycle assessment. I think many people hearing that for the first time will immediately have some sense of understanding about what it is doing. So, but it's very difficult, it's very difficult to kind of pick a name that suits everyone. And I guess the only other thing, that I would just flag is things like the way we see project level accounting or the policy and action standard from the GHG protocol is this very clear separation of you model the baseline, you model the intervention scenario, and things like the treatment of substitution within CLCA is slightly different from that. It's modeling. It's also including the avoidance of emissions that would just be reported in the baseline.
But as you said, this is mainly a presentation issue, and I mean we could easily present things separate if we wanted to. But I just think it's a problem if we are digging ditches instead of building bridges.
I agree. I agree. Yep.
Okay, so
can I just wade in there? I think you're both right, and it's important for the community to come together to be able to define these new nomenclature in a way that is more agreeable across board. So there is no this tug of war between the communities of practice as you've explained today.
okay, Jyoti, you've got your hand raised. Hoping I pronounced your name right.
Yes, hello. Yes, you have pronounced my name right. Thank you. Hello, Professor Matthew. It was a very nice presentation. I'm a PhD student right now, and I'm working on bioenergy policy transition. So basically, I'm working on energy decarbonization framework. So absolutely, what you have shown in today's presentation, that's what I'm going through. The depth I'm going in the literature, it is the same thing that LCA is doing. LCA is allocating different GHG this numbers to which it is it's escaping also. It's because it's very dynamic. The policy day by day policy is changing, and day by day our framework is also changing. So the LCA which we are practitioner using, that is leaving behind so many emissions. So that's what I want to know, that how to proceed in this changing environment. If I'm clear in my question, I don't know.
Yeah, I mean, I think it's just a very difficult question. I mean, and just to be clear, are you looking to apply a consequential LCA and you have a dynamic policy environment, and so your modeling has to change, or obviously there's lots of
okay, for that matter, I am looking for the supply chain life cycle. So for that matter, now we are using biomass in our thermal power plants for co-firing, right? That is one of our policy. So which is getting attention nowadays. Government is making mandate out of it. So in that, it is very difficult to quantify that number, because the byproduct of that would be in the ash, in the form of ash. And the things which I'm seeing on ground, emissions are increasing due to operational reasons also, and due to transport reasons also. So right, I am in a very difficult situation, that what to include and what to to how to make the boundary to incorporate in my study.
Yeah,
I hope you are getting me.
Yeah, I am. I mean, gosh, I mean, that is a huge question, and things like bioenergy, just it is very difficult. I mean, there are a couple of things that spring to mind. One is I mean, I'm not sure, but it sounds like you might be doing attributional LCA for the specific feedstock that you have coming in, and issues around traceability and so on, are always really challenging for knowing what, exactly where your feedstock is coming from, how it's processed, and so on. Yeah, I mean, this is
because it's a huge supply chain, right? Because start from the farmer and to the cement factory for that matter, right?
Yeah.
So
Yeah.
it's a huge supply chain.
Yeah, it is. I mean, one point I would make though, and this is, I think this is important because the kind of biofuel, bioenergy debate really brought to the fore methodological discussion on and the difference between attributional and consequential studies. There is a question when you're looking at something like the carbon intensity of your actual physical feedstock that you consume in your, if you're co-firing, there is a question about whether that is actually the right exercise to be doing. And arguably, if you want to know the total change in emissions caused by the decision to co-fire with biomass, then what you want to be looking at is the marginal supplier of the biomass, or the marginal system that changes as a result of the increase in demand for biomass, I should say. So it really depends on what you want to know. If the exercise is to know the change in emissions caused, then you should really, methodologically, it makes sense to be doing a consequential study rather than an attributional study. So you might spend a lot of time tracing your physical value chain, supply chain, but if that isn't the marginal system, then it's not telling you the change caused by your intervention, and that's a problem that you see.
I'm trying to get the primary data from field. I'm doing this field survey. So right now I'm visiting plants and try to, but that's still because every plant have different data, and when you are applying those method LCA or any software when you are using, you have to give a particular number, right? The example you gave it that around 33% of emission it didn't count it, right? So even in consequential LCA, it is very difficult to quantify that thing. If when I'm applying for a supply chain.
Yeah, but I suppose my point is it's a slightly different exercise. For consequential LCA, your question would be, how do we identify the marginal system that changes as a result of increasing demand for biomass, rather than how do we quantify the emissions from the physical feedstock that we are physically consuming. So, there's both challenging but different exercises. Yeah.
Yeah. Okay, great. So
just one last question, just one last thing I want to ask. Do you, Professor, want to work in this area? Do you want to go in this field? Because I would like to have, I'm looking for some collaborative works. So
yeah, I mean, well, please feel free to send me an email and I can follow up separately.
Sure. Thank you, Professor.
Thanks.
Okay, great. We've got quite a few more questions. I'll try to blast through them. So there's a few questions just on the clarification of how you would perform MOA or a consequential life cycle assessment with temporal stuff added to it. So just trying to find the questions. Okay, so to clarify, would MOA be much more work as you have to calculate the CO2 for each time point, or do you calculate the emission factors of the background data for each future time point?
Gosh, is it much more work? I suppose structurally, you have more data points, and then you'll be if there is dynamism, if there is change in the emissions factors over time, then you will be dealing with more emissions factors. You need sort of time-stamped emissions factors for for each period of time. So
Yeah.
there is, structurally in terms of data requirements, there is a greater data requirement. But the reason you do it is because it then gives you information that you otherwise wouldn't have.
Yeah. And in terms of like data used in these types of studies, are they similar to LCA databases, or would it be very different databases and softwares and tools used to do these types of analyses?
Yeah, that's a good question. I mean, to be honest, MOA often, if I'm doing an MOA study, then I will use LCA databases. If a database has a good sources of marginal emissions factors and so on, then absolutely. But also MOA, and I mean, this is it's quite a flexible method, so you can bring in any kind of modeling technique that you want to, that is useful for identifying emission sources or sinks that change and quantifying what those emission sources and sinks might be. So, in some cases, if it's a policy level intervention, you might use a general equilibrium model as an input to your MOA, and and you can use a suite or a range of different models to fill in different parts of your assessment. But yeah, absolutely. I mean, you can use LCA databases as an input to the overall assessment.
Okay, great. And in terms of like MOA and like, because you've talked about quite a bit about bio-based and bioenergy-based systems, like how would MOA handle something like indirect impacts such as land use change? So like in biofuel-based systems, indirect land use change is something that the LCA community is still arguing about 10, 15, 20 years later.
Yeah, and it is challenging, and within that space you can use things like general equilibrium models to identify world regions that are likely to respond to price signals as a result of changes in market demand and supply as a result of a biofuel or bioenergy policy. You can also use sort of less sophisticated, simpler models, sort of simple cause and effect models to predict areas of the world where you think the change is going to occur. And you can just look at things like simple statistical trends. So look at parts of the world that are expanding agricultural area. So there's lots of different ways of doing it, and each of them have their pros and cons. Some are just very resource intensive. Often general equilibrium models are something of a black box. They're difficult to understand, but they do give a kind of high level of sophistication. And yeah, so you can kind of pick a range of different models. You can use multiple models to see if they all point in the same direction. But yeah, with indirect land use change, the arguments are the same within the LCA community. MOA as a method doesn't change the pitch on the complexity of trying to model something like a market mediated effect like indirect land use change.
Yeah. Okay, great. So this is gonna have to be the last question as it's just turned past. But in terms of like, because benefit of consequential LCA/MOA is the temporal. You can see the impact with temporal change. But getting emission factor data or emissions data that is time variable or does have timestamps can be a bit challenging. So I was just wondering what your suggestions are on how to or what the process would be to try to get that kind of data, because there is prospective LCA where you can apply integrated assessment models to LCI data to try to get to turn the life cycle inventory data to something that's future orientated for different SSP scenarios. But I was just wondering what would be the typical procedure for MOA/consequential life cycle assessment?
Yeah, I mean, sometimes you do get published time series of emissions factors, and you see this particularly for grid emissions factors. So the UK government publish projections for marginal grid emissions factors out to, I think, 2100. So that's one, if you're lucky, then someone else has already done some modeling work. But essentially, yeah, those numbers will be based on some kind of modeling work. And if someone else hasn't already done the work and published it for you, then you have to kind of do that modeling exercise yourself. And there are, you can do it fairly simplistically. If you have a projection for how a sector of the economy will decarbonize, then you can apply a sort of linear decarbonization rate to that sector. So if you're looking at something like steel, and you believe that sector is going to decarbonize to a certain level by 2050, you can apply a simple linear factor. You could do something more sophisticated that would actually look at step changes as different technologies are introduced at different times. Yeah, it's the kind of thing where, I mean, actually, perhaps there is some guidance on how to quantify a time series of emissions factors. And if anyone has seen kind of good generic guidance on that, then please let me know. But otherwise, it's the kind of thing that it would be useful to see published. Yeah, and this goes back to my point about the development of a generic standardized methodology that would give that kind of level of detail.
Yeah. Maybe that's something that you could lead and work on.
It's something I'd love to get to. So it's kind of on my long to-do list. Yeah.
Yeah, maybe the community can also rally behind you and support you on this endeavor, Matthew.
Yeah, just need to get someone to fund it.
Yeah, absolutely. Support would be great. Yes, please.
Yeah. Okay, great. So that's brings us to an end. So I'd like to thank everyone for joining, and really thank you so much, Matthew, for the wonderful presentation. It was really insightful, and yeah, just for some things very eye-opening. So thank you everyone for joining us today, and hope to see you in a future seminar.